Good afternoon, everyone. My name is Abeer Elshennawy. I'm professor of economics at the American University in Cairo. I'll be the discussant and moderator of this session. We are going to have 4 presentations, 2 online and 2 in person. We will start first with the 2 presentations online. And the first paper is Dust Storms and House Prices by Dr. Mohamed, Ahmadizadeh, Amirhossein, Amini, and Dr. Hadi Esfahani. And the second online paper is Price Elasticity of Residential Natural Gas Evidence from Billing Data in Iran. So we will start with these 2 papers. After each presenter will have 15 minutes. And then I will go on with my discussant comments, and then we will have 5 minutes of questions from the audience, and then we proceed to the second paper and so on. So please, Dust Storms and House Prices, Dr. Mohamed Ahmadizadeh and Dr. Amirhossein Amini and Dr. Hadi Esfahani, please go ahead. You have 15 minutes.
Hello, everyone. Thank you for this opportunity, and I want to also thank all the participants online and also in person. So this paper, Dust Storms and House Prices, is co-authored with Dr. Ahmadizadeh and Dr. Esfahani. I'm Amirhossein. I'm presenting the paper. So the research studied the effect of recent increase in the number of dust storms and exposure to dust emission on housing market in Iran. So this is probably the first hedonic model that look at the effect of dust storm on housing market pretty much anywhere. And one of the earliest paper on the causal impact of dust storm. These studies are both important in housing economics and environmental economics. In housing economics, along with other hedonic models, these kind of studies measure an impact of an amenity on housing prices. And also in environmental economics, since we don't have a market that put a price on pollution, we use housing market agents' reaction in housing market and their marginal willingness to pay to measure somehow the implied price of pollution. Our results show that the increase in number of dust storms in the past 2 decades is associated with a sizable decrease in housing prices, in house prices. We had 2 good housing data sets, one macro and especially the second one, the micro data set that we had, which was the raw data of more than 2 million observations of purchasing sales in the whole country of Iran, consisting of all apartment transactions in Iran during 2010 to 2017. Again, so it's a type of pollution. Dust storms are meteorological phenomena generated in arid areas. A strong wind lifts large amounts of dust particles from ground into air, carry them long distance. It can take anywhere from a few minutes to several days, leaving a layer of dust. So this is a visible type of pollution. And it has a serious adverse impact on economic activities and on health. There is a rich literature on the effect of dust bowl, for example, in the United States and its impact on agriculture and health, and also some studies on the Middle East. Countries in the MENA region are part of what that has been termed as dust belt. Due to global climate change and human activities, despite that, I mean, in addition to that, the incidence of dust storms has increased throughout the MENA region in the past couple of decades. So part of that is droughts, part of that can be explained by political instability. The interesting aspect of dust storm, at least in the case of Iran, is that it has external sources. So this picture is just to give you a big picture This shows a layer of dust covers cars and buildings in the city of Ahvaz in southwest of Iran. So not only we had increase in the level of dusty days, in the level of dust storm, but also the increase was heterogeneous. So if we look at the graph, the blue line shows the average number of dusty days, the red line shows the standard deviation. In the selected number of cities, major cities in Iran, we show here, some cities, I mean, many cities experience an increase in the level of dust storms, but the situation for some cities were more adverse. I mean, like, for example, city of Ahvaz, Kermanshah, they experienced a significant level of increase in the level of dusty days, but Tehran, for example, the capital, although it also experienced an increase, the level is not comparable. And again, this is based on this other study, Bulrani, 2014. The investigated sources of dust storm for Iran are mostly external. From Syria, Iraq, Saudi Arabia, part of that because of political reasons, instability in Syria and Iraq, and part of that again because of global climate change. Again, there are studies that look at the causal impact of air quality on house prices. Like earliest paper, like Wittker and Henning, 1967. Most earlier studies were correlational. In the past 2 decades, 25 years, we had a number of studies that look at some kind of policy variation as an instrument variable, for example, or a natural experiment to link to investigate the causal link between pollution and housing prices. There's a literature also, one of the most cited paper, Hornbeck 2012, that look at the effect of Dust Bowl in US on agricultural activities, for example. Number of other papers look at other aspects of US Dust Bowl. Number of papers also investigate the effect of dust in Middle East specifically. So, for example, the working paper of Birjandi and Yousefi look at the same similar phenomenon of increasing the level of dust storms in Iran, but they look at the productivity of industrial firms. Number of other studies look at increasing the level of dust in West Africa, and also some correlational studies also look at the effect of dust in Middle East. So these are the sources of our data. I'm gonna just briefly explain. We had weather data at a station level, individual transaction data, and also macro city level data, 86 ground stations in different Iranian cities. In this station, we had this data on a weather code, including reference to widespread dust suspended in the air, not raised by wind or near at the station at the time of observation, which code 06, which capture external sources of dust. Based on that, we constructed the share of dusty days. In our transaction data, we had the share of dusty days prior to transaction, like 1 month, 3 months. In the city level, we had the number of or share of dusty days in the year before the observed city level price. This also showed the distribution of the weather stations, pretty much covering most important cities, all geographically most areas in Iran. So finally, we could match data sets like 1,800,000 housing transactions across 66 cities were matched from the weather data to the housing transaction data that we had. And also we had the city level data from earlier period, because the increase in the level of dust happened in early 2000. Transactional data started in 2010, which was associated with this more significant increase in the dust storm. But we wanted to look at years before. Since there were no transactional data, we looked at the city level price indices from 1993 to 2016. Later, we used a more balanced panel from 2000 to 2016. So these are the observation. Again, at the transaction level data, we could construct share of dusty days as assign it to each transaction. 1 million and almost 800,000 observation. So just want to be fast, so finish it in 15 minutes. This is the model that we use in transaction level data. We have log of price of the transaction apartment J transacted in city I at the time T, share of dusty days, like here 1 month, 2 to 3 months, different intervals before the transaction. We had some information about the housing transaction, age, size. We also had city fixed effect. We control for year fixed effect, seasonal effect, and city specific time trend to capture different trend that we may observe in different cities. For the city level data, somehow similar model, but at the level of the city, this is the average in price index for city I in period T. We had the lagged share of dusty days during the half year, just before because we had the observation every 6 months in this panel data. City fixed effect, again, year fixed effect, city specific trends, we could still control for those fixed effects. We also make some changes. Equation 1 again assumes error terms are not autocorrelated and that the full effect of a city in each period on house prices has materialized the following period. Again, there's this problem with which tests of autocorrelation reject this hypothesis. So we had this alternative that we added this error correction term to equation 1 on the city level data, which was our panel data. And again, basically equation can be rearranged and we can estimate somehow linearly to obtain the coefficient of interest. So one other aspect is that we argue that these sources of dust storms are exogenous. In short panels such as ours, however, we may encounter a dynamic panel bias, that is city fixed effects are correlated with lag of the price. So it is also possible, as I mentioned, STD is not fully exogenous. In order to provide a solution for that, to deal with this, we employ a system GMM method as our third method of estimation for the panel data, city level data. In this method, we combine equation with its first difference transformed to address endogeneity in inefficiency issues in short panel. GMM has some instruments, specifically the second and the third log of price has been used, and also a STD, share of dusty days.
Dr. Ameer, can you please go to the results because you have 4 minutes left?
Sure. Like the results basically show among these different models show significance. I mean, like even when we limit our panel to a more balanced panel, the results are robust. In our transaction level data, we look at, as you see, we looked at the different periods before the time of transaction. Overall, we get robust, significant results on the effect of dust storm on house prices, whether it's a transaction price, transactional price, or city level price. Average of long run effects across data sets. For example, here alpha in our model was minus 0.51. An increase of 1 dusty days annually lowers house prices by 0.4. That's the meaning of the coefficient. Is 1 more day of dusty days associated with lower house prices of about 0.14%. 8-day increase, which is the average from 1990s to 2000 to early 2000, means almost is associated with decline of 1.1%. Additional 19 days, which is what happened from 2000 to 2007 to 2016, resulted in a further decline of 2.7%. The implied estimate for the total decline of the price that is associated with dust storm is 3.8%, which is a significant number for dust storm. Of course, as we saw, the impact was not uniform. If we look at this average effect and we apply the estimate to a city like Ahvaz or GholamReza, we see that price decline can be about 10.1, 9.3, or 8.8% in those cities that were more exposed to dust storm. Again, this is a hedonic model study, first hedonic model study on the impact of dust storm anywhere. We argue that because of the exogenity nature of the increase in the level of dust storm, we establish some form of causal impact, linking dust storm, this type of pollution, with housing prices. Basically, we estimate marginal willingness to pay of individual for a type of pollution. We use this unique data set, transactional level data sets, for all transactions, housing transactions that are registered in the country. And also the nature of these natural experiments, which was the regional variation. Some cities were affected more than other cities, was also important in the context of natural experiment that we had. Again, some policy relevance of this study, we can see the economic we can have an estimate of economic consequences of dust storm or economic value of this type of pollution, which also emphasize the need for international cooperation. The difference between dust storm with other sources of pollution like factory level pollution, gasoline induced pollution, is that dust storm is more like a regional international issue, arised by political instability, arised by global climate change, and addressing that needs some form of international cooperation. Of course, we can look at the impact of such level of increase in pollution, for example, to see the direct impact on health. This is generally a paper that estimates marginal willingness to pay of individual, but we can look at this on other important economic or health factors. That's pretty much it. Thank you for listening.
Thank you again, Dr. Ameer, for this very interesting presentation, very interesting paper. Just to summarize, the paper focuses on the effect of dust storms on house prices in Iran, which opens the window on the broader economic effects of environmental degradation. The paper is first to analyze the causal effect of dust storms on housing prices and find that an increase of 1 dusty day per year lowers house prices by about 0.14%. This implies a drop of 1.1% in average house prices between 1990 and 2008, and a further decline of 2.7% during 2008-2016, adding up to a total loss of about 3.8% in the average house values between 1990 and 2016. Now, I have just a few comments on the paper. The model, the estimated model, does not include other variables like other measures of air quality, like air pollution. And we would like to know, how does dust storms affected construction of new houses? If they are so frequent to happen, if these have the construction of new houses have declined, we would expect this to mitigate part of the decline on the already existing houses due to short supply. Lowering housing prices while hurt owners can benefit buyers. So how can the paper take account of such effects? So we would like to see how dust storms affected construction of new houses, and how the fact that it benefits buyers, how can this be accounted for in the paper? And what were the policies introduced to mitigate dust storms in Iran, if any? And also, I'm curious to know, do Iranian people believe that dust storms are man-made? They actually believe that it's man-made, and therefore they protest against it. Is this actually materializing or not? Otherwise, this is an interesting and very well written paper. You may choose to respond to these comments now, and afterwards I will open the floor for 5 minutes discussion from the audience.
I mean, very good comments. Yes, like for now, like we didn't include, for example, we have probably city level data on some economic variable. It's a little bit difficult to find, for example, pollution level for cities other than major cities. Like, I don't know, PM 2.5 is not available for cities that are less than 1 million population, probably. But like there are other um, like climate related variables that we can control, like, I don't know, amount of rain, temperature. On the construction, very good point. Probably we can get the number of construction certificates that is issued by city. That's a good thing to look at that, because that's an external change in the supply, in a sense. Whether it is buyer or sellers benefit, I mean, overall, these kind of hedonic model look at equilibrium price. The implied effect is on the equilibrium price. So overall, it includes both effect of what is happen to buyers if they are willing to pay less because of the pollution, and also sellers if they want to sell more and probably leave because of the pollution. On the policies, yes, there are some policies to combat, for example, desertification, but yes, it was not successful, mostly probably because the sources of dust storms in Iran are not local. We're not, at least the recent increase in the level of dust storms were not local. It resulted in some riots, especially like I showed you the picture of the city of Ahwaz. In a sense, they blame probably government. Yes, I mean, like the situation overall invites protest, but when we have that level of increase in dust storm, and they basically believe that government can do something, whether it is a kind of like regional cooperation with Iraq or Syria or Saudi Arabia. So at the end, they somehow blame government. And yes, like a good number of riots has happened. I think we cited some of those in the paper. It has political, I mean, good point. It has a political outcome implication. But overall, yeah, thank you, especially like for the comment on including some variable on construction. Thank you so much for the comments.
Thank you. I now open the floor for the audience to ask questions. Yes, please go ahead.
Thank you. My name is Nader Habibi. Thank you for your presentation. I was wondering if you have given any thought to the possible effect of the water shortage and how that should be taken into account in your analysis, because in the same way that dust storms have had an adverse effect on housing prices and motivated migration, some cities have suffered from water shortage as well. How do you separate the effect of water shortage from dust storms in your analysis, if there is a way of looking into that? Thank you.
Here, please.
Thank you so much for the interesting presentation. This is Asma Hatab from Uppsala University in Sweden. I have few comments because we are working on a similar paper like this, focused on Saudi Arabia. And I can share with you some insights from what we have found. The first thing, and this is a question to you, to what extent you think that a lag duration of up to a year is sufficient? Because, you know, like the decision to purchase housing units requires a long-term planning, and you may need to consider a little bit the length of this, the lag of the variables. The other thing is you mentioned briefly about the city-specific characteristics, and I'm not sure if you have accounted for example, the green landscape within the city, because we have used satellite images from Saudi Arabia, and we were able to find that the kind of the quality of the green spaces also absorb, we accounted for this by the number of trees which absorb and kind of mitigate the impact of dust storms. The third thing, and this is actually inspired by a presentation yesterday about the sanctions. I know very little about Iran, but I understand that the economic pressures from sanctions may also have affected market dynamics. So have you accounted for that?
Any more questions? Okay, please, Dr. Abeer, you can go ahead.
Okay, again, thank you so much for the comment. So some of these variables, like again, controlling for all of these variables can be useful, but the variable that we are concerned about is the variable that mimic the pattern of dust storm. So we need to be concerned that the effect that we get, and we believe that it's the effect of dust storm, maybe it's the effect of something else that we are capturing in the paper. So on the water shortage, again, if we have a variable on water shortage and we can control for that, it doesn't harm. The thing is that when we look at the pattern of dust storm increase, cities in west, even northwest, and especially southwest are mostly affected. So it's not necessarily the cities that have water shortage problem, like the cities that are located in the deserts in the middle of Iran that has the problem of dust storm. Again, the sources of dust storm are not local. That's what we claim. And also the data that we are looking at is capturing the increase in the level of dust storm that is not sourced locally. But again, all these local variables, anything related, as you mentioned, water shortage or economic variables, controlling for them is going to help. So for the lag duration, if I remember correctly, the further that we included the lag in our city level data, we didn't see the result, any significant results. So one lag for the city level data, one lag had enough explanatory power. But for the transaction data, actually, we also look at, for example, 1 month, just 1 month before the time of transaction. And yes, like overall, your comment is correct that maybe it's a too short period of time, like 1 month for the people to make decision whether they want to choose a location, whether they want to buy a property or not. Overall, maybe we look at it like this: when you go and purchase a house in this hedonic model, pollution in the hedonic model is an attribute, and if the weather is not good, if we have air pollution before the time of transaction, it should have negative impact, at least psychological negative impact, on the price that you are willing to pay for the transaction. But again, like we look at the effect from 1 month all the way to 1 year before the time of transaction. On the city level characteristics, just like my previous response, as long as it's good to control, like we plan to include at least some economic characteristics of the cities. Currently, we just have these dummy variables and city-specific trends and fixed effects. But as long as this characteristic is not mimicking the pattern of heterogeneous increase in dust storm, it should not cause an issue for our estimate. On the effect of sanctions, that's a very good point. We believe that if we have the effect of sanctions since 2000, it should have impacted. It should not have a geographic variation of impact. Yes. So if we have sanctions, a city in West should be affected at the same level that the city in East. That's an assumption. Yes. Or we should come up with some measure of sanction effect that varies geographically over time. And if the issue is that sanctions affected Western cities, for example, more than Eastern cities, then and it happens exactly at the same time frame, then that will be an issue. And again, like we look at time periods from 2000 to 2017, 2010 to 2017. So these are pretty much the time that sanctions, nuclear program sanctions, the major sanctions against Iran, started and implemented. But also, like in the city level data, we had data back to 1993. Changing the time span did not significantly change our results. But again, like, good point. For example, maybe sanctions had less impact on the capital, Tehran, which, like, people are mostly high income compared to the average in the country.
Dr. Amin, I'm sorry, I have to interrupt because we have to move to the other presentation because we're short on time.
Sure. But no,
thank you.
Overall good comment. I hope I could respond.
Thank you very much. And now we move to the second online presentation, Price Elasticity of Residential Natural Gas, Evidence from Billing Data in Iran, by Dr. Mohamed, Mahdi, Jafari, and Dr. GholamReza Haddad. Please go ahead. You have 15 minutes.
In the name of God, hello everyone and good afternoon. I'm Mohammad Mahdi, and today I'm presenting a joint paper with GholamReza Haddad. I'm so glad of this opportunity to share with you our work, and I'm sure that comments from participants will be extremely valuable for improving our work. And I would like to extend my special thanks to the ERF organizers for making this possible. So let's begin the presentation. To begin, I'd like to highlight why studying natural gas is important and why we focus on it. Well, natural gas is highly important from multiple aspects. According to EIA, 35% of total US energy-related CO2 emissions is due to burning natural gas. And given these environmental issues and environmental concerns, price mechanisms are widely employed to regulate and limit the emission of CO2 and greenhouse gases. Natural gas is a major contributor to CO2 and greenhouse gases. So we need to know to what extent price tools, such as carbon taxes, are effective. Welfare implications is another aspect of environmental policies. So policymakers need to know who bears the burden of green taxes. Studies such as Keleven, Chekki, and Harberger propose that price elasticity is the only key parameter which can be used to estimate the welfare gains of taxes. So to answer these key questions, we need to estimate price elasticity, and it is a crucial parameter for effective policymaking. Natural gas is also important and plays a pivotal role in Iran's energy landscape, as 70% of Iran's primary energy consumption and 80% of electricity generation is reliant on natural gas. Among different sectors, the residential sector consumes a significant portion of natural gas, peaking at 45% during the cold season. To estimate price elasticity of natural gas, we use the billing information from households across the country spanning 8 years. In our dataset, we have unique IDs for each subscriber, 10-digit postal code, the starting and ending date of the billing period, the amount of consumption during each billing cycle, the amount of the total cost of natural gas consumption, and the number of dwelling units per each subscriber. You can see the number of subscribers by province in Iran. Natural gas network is quite extensive, and it is spread all across the country to urban and rural areas. Now let me break down the Iran's natural gas pricing system, because it is a bit tricky and complex at first glance. Natural gas price differs geographically across the country based on location. All cities in the country are categorized into 5 climate zones And each climate zone has a distinctive 12-tier increasing block pricing system. You can see the block pricing system and marginal prices for natural gas for each climate zone. In climate zone 5, which is the warmest area, marginal prices jumps very quickly and faster than other zones. There are two major price shocks in within the time frame of our data set, which we focus on it. One in 2014 and one in 2015, with quite different patterns. The price reform in 2015 has the opposite pattern compared to 2014. In 2014, the first block of consumption experienced a big shock, nearly 45% increase in natural gas prices. It is worth noting that Iran's natural gas supply chain is completely government controlled, from upstream production to downstream distribution, pricing, and etc. All is done by a single national gas company. And we take advantage of this unique setting, because in this unique setting, price reforms can be considered as exogenous shock to households. That's because natural gas prices are heavily regulated, set by the government, and completely isolated from market forces. Natural gas price is not determined by the interaction of supply and demand in Iran. Let's move on to the methodology. Considering this baseline specification, where Q is the daily average consumption of natural gas per household, and P is the average unit price of natural gas or marginal price. We also control for household fixed effect and a bunch of dummy variables for time, including month, year, the interaction of month and year, and city by month and year. Well, regarding indigeneity issues, block pricing system poses a significant challenge for identification. As you can see in this example of a two-tier increasing block system, both marginal price and average price increase as a mechanical function of quantity consumed. Given the quantity of consumption, marginal price increases. For example, if consumption is more than C star, marginal price is P2, and if it is less than C star, marginal price is P1. And average price is calculated by dividing total cost by the total amount of consumption. So how do we address this indigeneity issue? Well, we take two approaches. First, we use the first leg of price to break price relation, and then we combine it with a simulated instrumental variable approach. Incorporating first leg of price in panel estimation help us break the quantity price relation, because the prices in T-1 is not a function of the future consumption in time T. On top of that, studies show that consumers respond to price signals when they feel and when they pay the cost of the bill, and it's after the billing cycle. So using lag of the price helps capture the behavioral responses as well. Combining this approach with simulated IV, which is borrowed from the taxation literature, where similar challenges with a progressive tax system, when there is similar challenges with a progressive tax system, here I'll briefly explain the core idea of simulated IV. The intuition is that we use the household consumption history before the price reform, before the price shock, to predict their expected consumption after the price shock and the corresponding average or marginal price. So to do this, we do this in 3 steps. First of all, we use consumption in the same month for each household. We use the consumption in the same month 1 year ago to predict their consumption after the reform. It is just a matter of prediction. And we can, based on this hypothetical consumption, we calculate the simulated price based on the pricing system for each climate zone. And then we use, in the second step, we use this simulated price as an instrument for the realized or actual price. Finally, we regress log of quantity on the instrumented realized price. Now let's take a look at the results. In this slide, you can see average unit price elasticity of natural gas. As I mentioned, there are 12 tiers of consumption, 12 blocks of consumption in Iran's pricing system. And we have estimated the price elasticity of natural gas for all tiers of consumption. All coefficients are statistically significant, and there is an interesting pattern in the price elasticity of natural gas. You can see it in this slide better. The elasticity for the consumers in the lowest level of consumption is the smallest one, and it is relatively small because these consumers use natural gas at the minimum level only for necessary demand. But consumers at the highest level of consumption have more capacity and more potential to save natural gas. And so they have a larger elasticity and they show more sensitivity to price signals. For the sake of robustness check, we substitute marginal price for the average price, and the results are quite the same, similar to the average price. And I'll skip this part for sake of time. And at last, we find substantial heterogeneity in price elasticity across the seasons of consumption. As you can see, in the warm period of the year, there is a large price elasticity of natural gas, nearly minus 0.12, and there's a relatively fairly small elasticity of natural gas in the cold season of the year. Our
Jafari,
findings highlight.
Please move to policy implications, because you have 3 minutes left.
Sorry, I didn't catch it. Can you repeat that?
Can you please proceed to policy implications because you have 3 minutes left?
Yes. It's the last slide, the final slide. Our findings highlight pronounced heterogeneity in price elasticity, both seasonally and across the consumption tiers. High consumption households display greater sensitivity to price changes, representing more capacity for saving. And the lower elasticity observed in winter underscores the necessity-driven nature of heating demand. We believe that these findings provide a strong empirical basis for designing targeted pricing reforms that enhance efficiency while protecting the low-income household from adverse welfare impacts. Thank you for your attention. And I would be happy to answer any questions or thoughts.
Thank you. Thank you so much, Dr. Jafari, for this very interesting presentation. I will now proceed to my comments. So this interesting paper highlights the importance of natural gas in the energy transition and estimates the price elasticity of natural gas in Iran. The paper argues that estimating the price elasticity of natural gas is essential to assess the effectiveness of price reforms in managing demand in the residential sector. In the specification of the model, it would be helpful to add characteristics of the house. For example, if the number of rooms is bigger, I would see that there is a bigger demand for natural gas. So including this as an explanatory variable would be helpful. It's also helpful to add some characteristics of the household, like level of education, since well-educated households can conserve on energy demand. In the conclusion, it's important to explain how the policy implications differ from those documented in the literature. to highlight the contribution of the paper. There's also a need to highlight what new the paper brings to policy making in Iran compared to what is already implemented. Okay, any questions from participants?
Thank you very much. I'm Nader Habibi. When I looked at the elasticities that you showed, they range from very small minus 0.02 to minus 0.16, which means that they are all very small, even though there is a variation, but we don't see any significant variation. And perhaps it's because there is still a large amount of subsidy offered on natural gas price, which even the very rich who face the more expensive prices are not really that sensitive, because they have, it's not such a significant price for them. Could you comment on that and the variation in price that the lower income, low consumption and high consumption people face? Thank you.
There's also a comment from the online audience. A great presentation, Jafari. I'm wondering whether the coefficient suggests that demand is largely inelastic. Kefa from the Economic Scholar Panel, University of Nairobi, Kenya. You can briefly please respond to these questions so that we can move to the other presentation.
Yeah, thank you for your comments. On the low elasticity of natural gas, the main reason is that the level of natural gas prices in Iran is very low. And as we expect, and consistent with the theory, price elasticity is also very small because the prices are very low and they're highly subsidized. So I think that the comment from Mr. Habibi, Nader Habibi, is a good point, and it applies to the Iran's context. Considering inelastic demand, I don't think that the results suggest an inelastic demand. Price elasticity is maybe low, maybe small at the low level of prices, but as we saw in the results, as I mentioned in the results, price elasticities increase with the level of consumption and with the level of prices, because prices are larger at the higher level of consumption. So if the government raises the level of price, natural gas price, especially average unit price, not marginal prices. If they effectively raise the average unit price of natural gas, we can observe larger price elasticities, similar to other studies and in the literature of demand estimation for natural gas.
Thank you so much, Dr. Jafari, for your responses. We now move to the in-person presentations, and we'll start with water scarcity and improved water use efficiency in Tunisia by Dr. Maha, Mili, Dr. Mohammad, Adel, Dhif, and Dr. Houyem, Chekki. Please.
Hi, welcome everyone. I am Mili, PhD student from the Laboratory of Economics and Industrial Management at the Tunisia Polytechnic School. So I'm honored today to present our paper titled Water Scarcity and Improved Water Use Efficiency in Tunisia using a computable channel equilibrium analysis. So this paper was co-written with Professors Mohammad, Adel, Dhif, and Houyem, Chekki. So today we'll be covering the following points. We will start with an introduction to provide an overview of the Tunisian context and the main research questions. Then we will present the methodology employed in this paper. Next, we'll present the simulation results and discuss them for future public policies. Did you know that in 2022, Tunisia exported more than 3.9 billion cubic meters of water? This may come as a surprise, but it highlights a hidden reality behind our exports of agricultural and food products. In fact, in Tunisia, the agricultural sector stands as the highest water-consuming sector, annually accounting 75 to 80% of the country's total water withdrawals. This sector plays a key role in Tunisia, significantly contributing to its GDP and represents around 11% of the country's export revenues. It is also a major employer, especially in rural areas, providing around 14.5% of the country's workforce, with around 45% of rural employment for women. However, the sector is facing numerous challenges, including the country's the high siltation rates and the inadequate irrigation infrastructure implemented by farmers in their fields. Given the current climate patterns and the increase in temperature levels, projections by the Tunisian National Institute of Meteorology show that in the coming years, Tunisia is expected to face a decrease in annual rainfalls, along with an increase in demand for water resources, negatively impacting the country's water supply-demand balance, which will negatively impact as a result the country's production levels, food security, and the country's trade balance deficit. That's why in this paper, you will answer the following research questions. How do water shortages in Tunisia are expected to impact the Tunisian economic growth, and to what extent could water use efficiency policies remedy the negative impacts caused by climate change, or particularly water shortages? So to achieve our research objectives, different approaches could be used, such as partial equilibrium modeling, input-output analysis, and CGE model, computable general equilibrium models. So for a comprehensive analysis and to focus on the interactions between the economic sectors and their economy-wide impacts, computable general equilibrium models appear to be the most suitable based on our literature review. That's why we developed Agwatoon, which is an agricultural water-focused CGE model for Tunisia that was calibrated based on a social accounting matrix for the year 2016. So this model models the behavior of 4 economic agents, households, firms, the government, and the rest of the world. And it considers 3 primary production factors: labor, capital, and land. As for the economic sectors, so the sum considered, we worked on aggregating and disaggregating the economic sectors to end up with 5 economic sectors. We have the agricultural sector, the food processing sector, the water sector, the other industries, and the services. And for a medium and long-term analysis, we considered a time frame spanning from 2016 to 2050. So this is the production structure of our production, or the structure of our production function. So we started in this research, we started with 4 water-related hypotheses. So we have H0, which is a baseline or a reference situation with no water constraints. And then we considered H1, H2, and H3, 3 water-related hypotheses with different levels of decrease in water availability. The first one with 5%, with 10%, and with 14% respectively by 2050. And then we considered 3 water use efficiency scenarios. So with different levels of improvements, we have the first one with 5% improvement in water use efficiency that corresponds to the rehabilitation of water network infrastructure. And then we added to the rehabilitation of water network infrastructure, we added the modernization of irrigation infrastructure in the agricultural sector. And for the third one, we added also the use of plant varieties with less water requirements. Our analysis follows a sequential approach in which we will start by assessing climate change or water scarcity on the Tunisian economy. So the main focus will be on the agricultural and the agri-food processing sectors and their economy-wide impacts. And then we will consider the water use efficiency policies, which are considered as new investments in the agricultural sector. So we will assess, following the same approach, we'll assess their impacts on the agricultural and the agri-food sector and their economy-wide impacts. Our simulation, so we'll start with the water-related hypothesis. So simulation results show a decrease in the production levels of both sectors, with the agricultural sector. So there's our simulations show a decrease that ranges between 7% under the H1 to around 20% under the H3. The same impacts were observed for the food processing sector. So since given the decline in agricultural productivity, this will negatively affect that of the food processing sector. This decline in both production levels will lead to an increase in imports, which could be interpreted as a market response strategy or a solution to face water or to face food security issues. The decrease in production levels result in an increase in exports and in exports and an increase in price levels. So the increase in imports and decrease in exports result in an increase in the trade balance deficit by 2050, resulting, which will lead to a decrease in the share, the agricultural share in the GDP, and as a result, the Tunisian GDP by 2050. Also, our simulation results show that wage rates are also expected to fall by 2050 to reach around, so depending on the level of the reduction in water availability, which is resulting from the decrease in labor demand in both sectors, and which will, as a result, result in a decrease in the social welfare in Tunisia. To mitigate these impacts, so we suggested examining the water use efficiency policies. So simulation results show that the efficient use of water resources allow, let's say, eliminating a portion of the negative impacts caused by water scarcity. So as you can see here, we have an increase in production levels of both sectors, leading to a decrease in imports and increase in exports, which will, next slide, please, which will decrease the trade balance deficit by 2050. And this will result in an increase in the share of the agricultural sector in GDP and an increase in the Tunisian GDP by 2050 that ranges between around 0.5% to around 1.54% by 2050. Wage rates are also expected to increase, which will boost the economic or social welfare by 2050. However, with the increase in exports of agricultural and food products, our simulation results show an increase in virtual water exports. So the main exported products in Tunisia, agricultural and food products, of course, are considered as high intensive water products. So the increase in exports of these products will result in an increase in the virtual water exports. So Tunisia, being a water scarce country, has an interest in importing more water intensive crops while diversifying and broadening the range of its products that are intended for exports. So to conclude, so Agwaton was developed to analyze the impacts of water scarcity on the Tunisian economy, and we used it also to see how the efficient use of water in the agricultural sector could remedy these impacts. The impacts of water scarcity on agricultural products result in higher trade balance deficits and lower GDP, while on the other side, improvements in water use efficiency allow, let's say, to remedy these impacts, and the impacts are higher when the percentage of improvements in water use are higher. So this shows that combined strategies could have higher potential in altering the implications of water scarcity in Tunisia. So based on our simulation results, gains resulting from these scenarios show that some policies need to be implemented, like the infrastructure rehabilitation, since water infrastructure in Tunisia, or maintenance of water infrastructure in Tunisia, is almost absent. So the rehabilitation of this infrastructure may help in reducing water losses. The use of more adopted irrigation infrastructure in the agricultural sector may reduce water losses during the irrigation process, since we have seen that in the introduction that water losses are around 40% of water used in irrigation is lost in Tunisia. Promoting the use of non-water intensive and temperature resistant crops is also recommended. So research in this field is highly recommended to identify the most suitable crop varieties given the country's climate conditions, or, water availability, etc. Reducing exports of water intensive crops is also important for Tunisia we should work on broadening the range of products intended for exports. And finally, yeah, that's it. So this study has several limitations that need to be addressed in the future. Further, maybe segregation of the agricultural sector and the differentiation between rain-fed and irrigated agriculture is recommended. We also recommend adding the regional dimension in this model. So in order to take into consideration the climate disparities between the different regions in Tunisia and the water resource availability. We also recommend for future public, we recommend studying or seeing the impact of other additional policies for simulation, like the use of the unconventional water resources or the taxation policies. Thank you for your attention. And
thank you so much, Dr. Maha, for this very interesting presentation. Now I'll move to my comments. The paper investigates how water shortages will affect economic growth in Tunisia and how efficient use of water can help mitigate such adverse effects. The paper uses a recursive dynamic CGE model. It was not clear to me how the reduction of water availability was modeled. Is there a water sector independently in your SAM where you how did you simulate the effect of reduction in water availability? And you just focus on water reduction on agriculture, while other sectors also in manufacturing can be affected by water shortages. So we would like to see what other sectors are affected. The paper mentions declining wages rates as a result of water shortages. We would like to know in which sectors, which type of labor, and by how much. What are the constraints facing Tunisia when it comes to reducing water-intensive crops? Are these related to food security? And the first response to water shortages should be reducing water-intensive crops. So what is the constraint here? Also, it would be helpful to highlight model closure rules and discuss the implications of changes in these rules, like allowing for flexible exchange rate and fixed trade balance. So you may respond briefly to these.
I can see the first question so that yes, thank you. So thank you for your remarks and questions. So for the reduction in water availability, it was modeled in the water sector. So we the productivity. So we have a productivity factor and the equation of the water sector is production. Yeah. So it was the shock was introduced there to achieve 5%, 10%, and 14% by 2050. So it was decreasing. As for the impacts on the agricultural, on the other economic sectors, yes. So we wanted to focus only on the agricultural and food processing sector in the first step, but we are working on the other economic sectors, especially for another paper later. And for the declining in wage rates, so we have only one wage rate. It's not per sector. So we can't see the impacts on the wage rate for each sector. It's the I don't know how to say it, but it's the same wage for the entire economy. So
okay, so you have one type of labor.
Yes. But we can work on disaggregating the labor as a production factor into different types, and then we can see it by sector and by type of labor. Yes, so this can be, we can work on that in the future. Thank you. The other questions, please. Okay, for the water-intensive crops, in fact, so these crops are so they constitute a high value, let's say, for Tunisia. So like olive oil, dates. So they are the main exported products, and so it can't be and tomatoes also, and tomato-based products are highly demanded in European countries, so we are exporting them.
So Tunisia is exporting water-intensive crops.
Yes, that's it. And
so it's exporting water.
It's a veritable exportation of water resources. Yes, that's the point. And for the model closure, yes, so we are working on trying different closures for the model to assess the impacts and to see the different impacts depending on the closures considered, and especially for the fixed exchange rate. So yeah, we are working on that. Thank you.
Thank you so much. Any questions from the audience? Okay. Thank you very much. We will move to the last presentation. Last but not least, of course, teetering on the brink of death and hunger, Dr. Assem, Abu Hatab, and Dr. Emmanuel Orkoh. Please go ahead. You have 15 minutes.
Thank you so much for the opportunity to present this work. We are going to focus now on a completely different region, North Africa and Sub-Saharan Africa. In my presentation, I'll be mainly focusing on Sub-Saharan Africa because this is the main focus of the project, but our data set includes all North African countries. This work is a collaborative work. The study is actually financed by SIDA. SIDA is the Swedish International Development Cooperation Agency, and we are also receiving support from the United Nations Food and Agricultural Organization, FAO. So in this work, the objective, as you can see from the title, is to investigate the links between external debt in Africa and food security. If you look at this picture here, you see that from the year 2006, African countries have indebted. They have been increasing their demand for external debt for different reasons. One of this was the low interest rate in the period from 1996 to 2006. It was also the high investment needs and the limited progress that have been made in relation to managing external debt and the finances of the countries. So what we can see here that the level or the amount of external debt has increased by 3 times from 2006 to 2021. We can also see here a very interesting pattern that the composition of creditors have changed. We can see here that African countries are more relying on bilateral and private debt. These have been increasing significantly over the research period. We can see here that there have been new players on the debt market in Africa, where China, for example, holds about 2/3 of bilateral debt within the region. So what we can observe from this is the increased rate of external debt, the changes in the composition of debtors, and the new players that you can see here, like China, and the increased rates of bond issuance in many African countries. Next, please. So it's not only the accumulation of debt, but actually it's also the debt servicing. What we can see here is that 60% of sub-Saharan African countries spend on debt servicing more than their expenditure on the health and education sectors. So it's actually not only the debt stock, but also debt servicing. And this is very important limitation in the literature that I'm going to show how we have addressed it, because we assume here that it's very important to divide debt into debt stock and debt servicing because they may have different impacts on food security outcomes. Next. For those who are not familiar with the food sector and agriculture, so food security is a situation, it's a multi-dimensional concept. And this is very important because the majority of previous studies used to measure food security from a single dimension, mainly using a proxy like food prices. But if we go back to the original definition of food security, it's a situation which exists when all people have access to sufficient food at all times. And therefore, we always work with a number of 4 to 6 dimensions, including availability, economic and physical accessibility to food, food safety and quality reflected by the utilization dimension, and stability. And recently, the high-level panel on food security have added agency and sustainability. So one of the limitations in the research, previous studies, that they have always focused on the affordability and the economic access to food. And in this study, we are disaggregating the food security concept by accounting for the 4 traditional dimensions of the food security. The pathways to food security are multiple. There macroeconomic instability, which result from increased demand for external debt, can affect expenditure in agricultural sector, spending on food, sectors, improving food security, strengthening safety nets. There's also impact through inflation, impact through imports. 80% of food that was consumed in sub-Saharan African countries in recent years was imported. There are also some kind of debt pressures that lead to austerity cuts, and this reduces investment in agriculture and the prices of fertilizers. And you can imagine what happens when problems like this happen during times of COVID-19, with the Russian invasion of Ukraine. So it's a very complex situation. And as you can see, that the interplay between increased debt and food insecurity can lead to a vicious circle where each of them affect and trigger each other. That's why we have a main issue here in the estimation related to the endogeneity problem. Next, please. So maybe if you go to the next one, and then we come back to this one. So like we identified these 4 gaps in the literature. No previous study had investigated the relationship between external debt and food security in sub-Saharan Africa. Most of the previous studies focus on the links between external debt, economic growth, unemployment, labor market dynamics, and many other macroeconomic indicators, but no study has done this before. The second thing, as I mentioned, that we relied on studies related to risk, different types of risk. And what we can observe is that, again, they have narrowly defined food insecurity by focusing on prices. And I'm going to show you how we have divided this into different dimensions. We also have the fact that it's important to address both the debt servicing and debt stock, because previous studies have generally focused on the accumulated debt, the amount of debt. And most importantly, we think this is a major contribution of this work, that the literature focuses on the immediate impacts of food security, how external debt increases prices of food, availability of food, and other immediate effects. Very few of them focus on the long-term aspects. So what we have done in this study, if you go back to the previous study, so what we have done was to address all these gaps. We work with, we divide the debt variable into debt stock and debt servicing. We have considered all multiple dimensions of food security. We also have disaggregated our analysis by the level of countries' income and their food import dependency. And most importantly, we have used stunting as a proxy for the long-term impacts of food insecurity. Stunting is generally defined as the impaired growth and development among children under the age of 5. And it was measured in this study as the percentage of children whose height to age is below 2 standard deviations below the median of the international reference group, which is children between the age of 0 to 59 months. With this, we think we have a comprehensive assessment of the impacts both in the short term, but also in the long term. Next, please. Yes, so we use data from 32 African countries for the period 2012 to 2021. Food security was measured here using the Global Food Security Index developed by the Economist Impact. And the main index comprised of 68 unique sub-indicators. These indicators were weighted, and then we transferred them to a common scale. We normalized them. These normalized values were then transformed into scores from 0 to 100, where 100 is the most favorable outcome. Again, I mentioned that we included this stunting percentage. Yes. This is the list of the variables that are included in our analysis. We have the food security, the overall food security, affordability, availability, quality and safety, sustainability. We have the stunting. We have external debt stock, debt servicing, and a number of control variables. Most importantly, I'm not going to detail how we have addressed the endogeneity because previous speakers, the two presentations from Iran, have already talked about this, but we actually introduced this variable, infrastructure index, to mediate the relationship between external debt and food security. Infrastructure is important for the functioning of food value chains. We need a good infrastructure to move food from markets to consumers. And also financing infrastructure depends on countries' fiscal space and borrowing ability. So this was used as an instrument for mediating the association between debt and food security. Yes. This is just a distribution of food security indicators. And as you can see, countries like South Africa, Morocco, and Tunisia, they perform very well in almost all these different dimensions. We have countries like Madagascar and Chad, they perform very poorly across all sub-indicators. We have some weird phenomena where food might be available, but prices are very high. So we have this heterogeneity or these differences across countries. Yes. The model that was estimated looks like this. We have food security outcome, which is one of the sub-indexes plus stunting and the overall index. And this depends on food security in the previous year. We have the debt variable over time, either debt stock or debt servicing. And we have a vector of controlling variables that were presented, and the error term here. Similar to the two Iranian presentations, we have also used the GMM method. This is very useful, especially when we have a short period of time. Our analysis covers the period 2012 to 2021, and we also have a multiple number of cross-country observations. So this is a very powerful technique that was developed by Alirano and Boover in 1995. Yes, please. I'm going to highlight 5 main findings from this research, and I'm going to focus mainly on the debt variable. So what we can see here is that external debt undermines food security, overall food security. It also decreases affordability, quality and safety, sustainability, and it is associated with a significant increase of stunting among children. The only dimension that experienced increased or improved in food security was availability, despite that it is statistically insignificant. And this is actually, it makes sense because if you look at debt, debt is like a financial inflow. So it serves like a credit, not debit. So countries can use this borrowed money to buy food or provide or subsidize food for the population. But overall, we can see here that the overall impact is significant and negative as expected. The second main finding here is that debt servicing has a statistically significant negative impact on all dimensions of food security, as you can see. But what is interesting here is that the magnitude of the coefficient is very large compared to the debt stock. So we talk here about 12% decrease in affordability with any 10% increase in debt servicing. And this is uniform across all the dimensions of food security. Third, we have, again, because we have observed this change in the composition of creditors to the region, so we have divided this into multilateral, bilateral, and private. And what is interesting here is that the multilateral loans are associated with positive impact on food security. However, both bilateral and private loans are linked to deterioration of food security. And this actually is uniform for the food security and stunting, which increases with the bilateral and private debts. Yes.
Dr. Asim, could you please move to the post
I have one or two more slides. So we have, again, disaggregated this analysis by the income grouping of the countries. And again, we can see that most of the effect here is observed with middle income countries. This was a little bit surprising result because we expected low income countries to suffer more from debt, but it could be explained by the fact that low income countries have access to grants and funds, and aid agencies are more active in these countries, which may kind of buffer the impacts, but this was like a surprising to me. Next, please. The same thing here when we have considered the level of import dependency. We cannot see significant differences between very low to low import dependency and middle to high level import dependency. We can see that debt is associated with negative impact on food security, and it increases stunting significantly. Last point, and I should be thankful here for the reviewers of the ERF because they suggested that we should also consider the channel of effect, how this happens. One of the channels of effect is the impact on the value added of the agricultural sector, because the value added is a very interesting variable. It actually captured the net output of the agricultural sector after deducting the inputs. And what we can see here is that the external debt, increased external debt, is associated with a decline in the value added of the agricultural sector, which means that less funds available for investing in production and supporting consumers to improve food security. Next and last, please. I'm not going to go in details, but we have already published this policy brief, and our paper is now revised and resubmitted to World Development. But I think the most important finding that we emphasized in our recommendation is that, we need to consider the agricultural sector more seriously in sub-Saharan Africa. In the previous 2 decades, most of the interventions have focused on supporting or strengthening safety nets, supporting consumer, providing food to the communities, but these actually work like painkillers. They can actually mitigate the impact of food security, but they are not sustainable in the long run. So we recommend the prioritization of investments in sustainable agriculture to build the productive capacity of the sector and strengthen the resilience of agriculture to ensure food security for the population. Thank you so much.
Thank you, Dr. Assem, for this very interesting presentation. I now go to my comments. So the paper studies the effect of public debt stock as well as debt service on food security in Africa between 2012-2022, using a multidimensional approach to assess food security, accounting for availability, accessibility, quality, safety, sustainability, and adaptability. I think there is need to motivate more the focus on external debt rather than domestic government debt. And why exclude rural population growth, although it can be a source of increased demand for food, just like urban population? And why exclude the exchange rate as an explanatory variable in the model? I think that as the exchange rate depreciates, then it threatens food security, especially if you're importing a lot of food. And my last comment is climate change can also have an important effect on food security, and I didn't see that this is included. On page 7, it's mentioned that trade openness increases food security and affordability while decreases food sustainability and adaptability. It's clear how trade openness increases food security by making available imports and affordability through cheaper price, but why decreases food sustainability and adaptability? And in the conclusion, it's mentioned that debt service overall effect on food security is statistically insignificant. It would be interesting to explain why this is different compared to debt stock, and more discussion on how African countries can use debt to improve food security would be helpful. Thank you. You may respond.
Yes, sure. Maybe we go to the first page, the previous slide, please. Yes. Yeah, this is an interesting one. I think we were mainly interested in external debt, but we could actually justify why we did not consider the domestic. Maybe because this is like a funded study and the focus was mainly on external debt. We didn't consider it, but we see what comments we get from the reviewers. We actually account for urban population. And if urban population increases, so rural population decreases. And we've thought that focusing on urban could be more interesting because urbanization goes hand in hand with increased demand for food and mainly kind of calorie-intensive food. Plus, urban population mean that the labor force in agriculture will automatically decrease because people can migrate to work in urban areas or, leave the agricultural production. But I think with urban population, we already cover this. We didn't include exchange rate for some technical reasons, but we included inflation, and considering that countries in our sample spend more than between 60 to 70% of the household budget on food, we thought that the CPI could actually encompass all the effect that might come from external exchange rate. We included a variable related to the temperature in the analysis. So we used it as a proxy for climate change. It was easy to get data for that. And temperature is something that's observed across the 32 countries. I'm sure that you have read the previous version, because if you move to the next slide, you have a very interesting comment. Please move to the next one. Yes. Yeah, this one actually. We have actually redone the analysis. That's why when I was presenting now, I showed that the results are statistically significant and negative for the debt servicing, and the magnitude of the coefficient is larger than that for food, for the debt stock. We had some issue here, and during the revision, we changed the kind of the structure of the whole model, and now we have more convincing results. For this one, openness to trade, yes, I agree with you that the openness of trade may improve food security because it means that there's more supply to the domestic market, but sustainability and adaptability, if you look at the definition of this dimension in the Economist Impact Index, so it's more about the fact that like when you rely more on trade, this means that you are very vulnerable to changes in the international market. Think, for example, of the COVID-19 pandemic. Countries like Tunisia and some countries in North Africa are very open to trade. But when something happens to the global supply chain, when they are interrupted due to disease outbreak or a conflict between Russia and Ukraine, so the sustainability and the adaptability is an issue. So we think that trade is good because it can support during the stability, but when something happens, then the sustainability and the adaptability might be negatively affected. Yeah, we can of course consider this comment by focusing on how African countries can use debt to improve food security. That's a good suggestion. Thank you. Yes. But I'm really, really thankful because most of these changes were done after the comments. I'm not sure who has really done this interesting job and provided very useful suggestions. Thank you.
Any questions from the audience?
Thank you very much.
It's possible because we need.
Sure. Have any of the countries in your sample experienced debt forgiveness? And if they have, how have you treated that to see what is the impact of debt forgiveness on food security in the short run and in a dynamic manner? Thank you.
I think this is a very interesting comment, but luckily our data set covered the period 2012 to 2021. During this period, there has been no program for debt treatment or restructuring for the sample countries. The highly indebted poor countries initiative ended in 2006, and recently, after 2022, we have 4 countries in Africa, which are Chad, Somalia, Ethiopia, and Zambia. They are now actually applying for debt restructuring. So we didn't actually encounter this issue during the period of the study. But thank you so much.
Thank you so much all for joining us, and I thank the presenters for a very interesting paper, and thank you again.